Okay. So I'm going to go pretty fast through these, but if we come across something that you are struggling with, we can slow down and talk about it for just a minute as well. But my main purpose here, and the reason I'm going so fast, is just because I want to get to as many things as possible and just tell you, this is something you definitely need to know about. This is something you don't need to worry about quite so much. This is something that I'm not going to test you over, things like that. So here at the beginning, it's just kind of introducing you to chemistry stuff and the scientific method. I am not going to test you over the scientific method or that initial stuff about the just introduction to chemistry things. So don't worry about those. As far as classifying matter, you do need to know how to do that. So through this section here, it talks about solids, liquids, gases, and then elements, compounds, homogeneous mixtures, heterogeneous mixtures. I don't really have you classify things based on solids, liquids, or gases, but you should know the general properties of those things. You should for sure know how to classify things into these four categories here. So I could, and you will have questions over this on the exam. I think, and by the way the exam works is not everyone will see the exact same questions. I make pools of questions, and then the exam just pulls a certain number of questions from the pool. So you might see some questions that are the same as other people, but you'll see other ones that are different. So I made like 12 or so of these questions, where I just came up with 12 different things that would fall under one of these four categories, and it just pulls from that randomly. And so if you do 4 of these and 2 of them end up being elements and 2 of them ending being compounds, you're thinking, oh, I must have gotten one of them wrong because I didn't get any solutions. That's not necessarily true. It does just randomly pick them. So you might get 1 from each, and you might get 2 from one and 1 from another one. It is just truly random. But you do need to know how to classify things as either elements, compounds, homogeneous mixtures, and heterogeneous mixtures. You should also know how to classify different properties or different changes that happen as either physical or chemical properties or changes. So again, the key here is that if the actual molecules themselves are staying the same, so there's no chemical reaction occurring, and that's just a physical change or physical property that's being displayed. Chemical properties are displayed by actually changing the material itself. Okay, so then we get into the other big section of the chapter here, which is units. And by the way, you should definitely know how to do the physical and chemical changes, because that is also on the exam. You will be asked questions about that. When it comes to the units, the main thing that I'm looking for here is not an explanation of where the units come from or anything like that we talk about through this section. That was more just to introduce you to the topic. The main thing I'm looking for here is this, dimensional analysis. There will be a decent bit of dimensional analysis. I think it's either 5 or 6 questions. I forget exactly how many. But there's a decent bit of questions, a decent number of questions on the exam over dimensional analysis, where you will take a number with a unit and you will convert it to a different number with a different unit. So it's still the same value. You're still describing the same thing. It's just going to be a different unit attached to it. And there are varying difficulties of these as well. I did not make the difficulty random. I didn't just say, let's put all the difficult ones and the easy ones all in together and just, let fate decide. I did make different groups. I made a group of easy ones, a group of medium ones, and then a group of not difficult but multiple conversions need to happen ones. And so you'll get some of each on the exam. So be sure you know how to convert from one unit to another unit. just like we were doing here. So like converting from meters to miles, converting from miles per hour to kilometers per minute, from liters to cubic inches, things like that. This, by the way, this would qualify as like one of the harder ones because you do have to do multiple. There's a cubed unit in there. So the easier ones would be something kind of similar to this, where it's just one unit converted to one other unit. Medium difficulty might be something like this, where there's two units, one of them in the numerator, one of them in the denominator, and then the more difficult ones would be where you have cubed units and perhaps even like a cubed unit in the denominator, something like that. So you'll have examples of all those kinds. So there's temperature conversions as well. You should know how to convert from one temperature scale to another. Scientific notation, I don't think, I'm trying to remember, I don't think I put any questions in that are specifically just, here's a number, write it in scientific notation. But I know that I did put some questions in where scientific notation is involved, at least, where you should be able to read it. But I don't believe that I put any questions in where you actually have to do a conversion into scientific notation. And none of the questions require you to write the answer in scientific notation, by the way. But you should be comfortable using scientific notation, as well as unit prefixes. And this is more back to the dimensional analysis, essentially. Some of the dimensional analysis could be like converting from meters to kilometers, or from millimeters to meters. You know, converting inside of the metric system is one of the possibilities. So make sure that you are comfortable using these unit prefixes. All right, so then we have sig figs here. There are some questions on the exam over sig figs. They are either simple questions where it's just, here is a number, how many sig figs does it have? Or a simple calculation where I write out the calculation and ask you what the answer would be with correct sig figs. I didn't go too crazy with those. It's nothing, you know, you're not going to be solving the Schrodinger's equation with proper sig figs or anything like that. They're very simple calculations, even more simple than what you did on the labs, or maybe equivalent to some of the easier ones on the lab. But that is a possibility. Someone, I forget who it was, but someone wanted to go over sig figs real quick here. So essentially what we're looking at with sig figs is we are trying to determine the amount of precision that we have with a number. So if we make a measurement, so if I measure something with a ruler and I measure it and I find that it is 5 meters wide. So it is exactly 5 meters to the 10th place, anyway. By putting in this 0.0 here at the end, what I'm doing is I'm telling whoever is reading this that I actually measured it, and down to 1/10 of a meter, it is exactly 5 meters. Now, if instead I were to write just 5 meters, well, then the person that's reading is saying, well, is it exactly 5 meters, or is it 5.1, or is it 5, you know, well, maybe it's a 4.9, like, we don't know, because it wasn't specified. We don't know where it is inside that range there, because we didn't give very much precision with just this 5 meters. And so what sig figs are really doing is it's indicating how precise your measurements are. This is why we have these different numbers here. Each of these is a different value, even though they're mathematically they are exactly the same. This is showing that we measured it with more precision, and then this is even more precision. 1.00 grams is saying it is exactly 1 grams to the hundredths of a gram. We measured it with a better tool, essentially. And so when we're actually looking at digits, we're writing numbers down, we're reading numbers out of a book, certain numbers are significant and certain ones aren't. And any non-zero digit is always going to be significant. So 1 through 9 is always significant. The zeros are the ones that are a little bit different, depending on where they are. So if we have zeros between two non-zero digits, those are significant because they're giving us information about the number. Same thing with a trailing zero after the decimal point. So after the decimal point, you're saying here that I measured this down to the thousandth place, and it was still 0. Now after that, I have no idea. Could be anything but out here. But to the thousandth place, it was 0. But if the 0 is before the decimal point, scientists just agree that if you're putting zeros before the decimal point, the only reason to put this here is just that you know where the decimal point is. So the only reason these zeros are here is so that you know it's 1200 and not 12. There's no other reason to put those zeros there, because we could just as easily write this number as 1.2 times 10 to the 2, and that would only have 2 sig figs. So those zeros are only there to tell you where the decimal point is. They're not actually conveying precision. They're not actually saying that I know it's exactly 1200. Because if we knew it was exactly 1200, we could write it like this. Oh, sorry, that should have been 3. Oops. Should work on my scientific notation there. So yeah, 1.2 times 10 to the third would be 1200. And so then 1.200 times 10 to the third would be 1200 with 4 sig figs. Because now those zeros are after the decimal point. And so they are now conveying that, hey, I measured this all the way to this point and it was still 0. So for the same reason here, leading zeros are never significant. Because again, the zeros here are only telling us where the decimal point is. They're not actually giving us any information about precision. Okay. The person that asked me to go over that, again, I'm sorry, I can't remember who that was, but does that answer your question? Is there something you'd like me to go over more specifically?
No, that answered my question.
All right, awesome.
Thank you.
So, like I said, there will be questions over sig figs on the exam, but they should be pretty straightforward. Either just, here's a number, how many sig figs does it have? Or here is a simple calculation, what is the answer with correct sig figs? The last topic here was, oh, actually before I do that, you do need to, obviously, since there's a calculation there, remember the proper rules for multiplication, division, and then addition and subtraction. So addition and subtraction, the last common decimal place, that's as far as you can take the answer. And then multiplication and division, it's just whichever one has the fewest sig figs, that is the most that you can have in your answer. And then if you have a mixture, so like say we have 4.1 plus 8.1345 times, kind of ran out of space there, but let's say times 61.20. So if we had a combination of them like this, remember you do all the math the same, so you don't change the math for the sig figs, but you keep in mind what answer you get from this section here in the sig fig, or in the parentheses. So if I go ahead and say, well, I probably don't need a calculator for that, but oh well. 4.1 plus 8.1345. Inside the parentheses, I get 12.2345. Oh, that's interesting. That worked out that way. So inside the parentheses here, this is what the calculator gives me. And that's what I'm going to carry on through the rest of the calculation. So if I then multiply that by 61.2, I get 748.7514. But if I look at what, if this was its own calculation here, this addition, my answer would have to be cut off here, because that's the last common decimal place. Both of these numbers only go to the tenths place. And so my answer would be cut off at the tenths place, which means that it would only have 3 sig figs. And so 3 sig figs is then what I use to figure out how many sig figs I'm allowed with the multiplication step here. So I have 3 here, 4 here, because each of these are significant. So the 3 sig figs is limiting me, and so therefore my answer would be rounded to 749. Because 748, then the next number is 7, and so I would round that up to 9. Okay, so then the last topic here in Chapter 1 is density. You should know how to do essentially what we did here and on this slide. Just if I give you a mass, be able to find a volume. If I give you a volume, be able to find a mass. If I give you a mass and a volume, you should be able to find the density. So just simple questions like that with densities is all I'm looking for. Accuracy and precision, I did not ask any questions about those. All right. Chapter 2. Here at the beginning, we have some history over chemistry and the different theories and things like that. All I expect you to know from this section is that Dalton proposed the atomic theory. You do not have to know all 4 of the parts and be able to write a paper on each one or anything like that. Just know that Dalton proposed the atomic theory. Know that Thomson discovered the electron, and that Rutherford proposed the nuclear theory of the atom. Also you should know that Chadwick discovered the neutron. So it's those 4 things you should know. But all the rest of that stuff there, I'm not going to expect you to write a paragraph on the plum pudding model or anything like that. Just those things that I pointed out before. Okay, so now we're getting into the structure of atoms. The main thing that I'm looking for here is that you understand what the effect electrons have, the properties of electrons, just in terms of they have negative charge and they're very, very small. Protons are positively charged and they're the same size as neutrons, just general understanding things like that. I also expect you to know what happens when you change each of those. So like it's talking about on this slide, if I change the electrons, I get an ion, and I expect you to know anions are negative, cations are positive. I also expect you to know that when you change the number of neutrons, you get different isotopes. And if you change the number of protons, then you get a whole different element. I also expect you to be able to do what we did here on these slides, where you figure out how many protons, neutrons, and electrons an element has based on its chemical symbol. So there will be questions on the exam like this, where I will give you a symbol and you have to tell me how many protons, how many neutrons, how many electrons. I don't think I did any like this. What's the opposite? Where I tell you how many things there are and you have to tell me what the symbol is. But obviously you should still be able to do that. But I don't think I put any of those on there. Let's see, so now we're just getting into the periodic table, talking about where things are on the table. Since you're going to have the periodic table there with you, I didn't put any questions in like, where are the metals? Anything like that, just because you have it there, you can see it. But you should be able to use a periodic table, obviously, to help you answer other questions. I did not put any questions in there just about like, what is the property of a metal, what's the property of a non-metal. That was more just FYI. I do expect you to know, however, how to predict ionic charges. That is going to be something that's going to come up in the nomenclature stuff as well. So you should be able to tell just based on where something is in the periodic table what its charge is going to be. And in your preparation for the exam, I would even suggest, if you print off the periodic table, go ahead and write in on the periodic table, this column is +1, this column is +2, +3, -3, -2, -1, and then these are 0, because that's the noble gases. So you can do that in preparation beforehand. Let's see, the diatomic elements, I do expect you to know those as well. But again, since it's open notes, it's something you could go back and look at. But you should probably learn that just because later on, when it might not be quite so open note, you might need to remember which one of those, which 7 of the elements are diatomic. Let's see, so the atomic masses, you should understand that the masses from the periodic table are the weighted average of all the different isotopes for that element. However, I did not put any questions in where I have you calculating that yourself. So like we did here, where you take the decimal form of the percentage and multiply it by the atomic mass of that particular isotope, and then you do that for all the isotopes, and then you add those together to get the weighted average. I didn't put any of those in, but I do expect you to know what the mass from the periodic table is, and that it is a weighted average of all the isotopes. Alright, so now we're getting into stuff about molecules here. I do expect you to know the difference between covalent and ionic bonds. So covalent bonds are where electrons are being shared. Ionic bonds are where electrons are being taken. So they're completely transferred from one to another. So I do expect you to know the difference between those two and be able to just essentially say just that, what the difference is between those two. So the section here about chemical formulas, this is more just for your information. I'm not going to have you drawing molecules at this point because I can't, there's not really any way for me to do it. But it's more just for you to be able to read molecules like this, to be able to read a formula that I put up. You most definitely need to be able to read chemical formulas that I put up on the screen. And that gets us to the last topic here, which is nomenclature, and I guess there's a little bit here about forming ionic compounds as well, which is related to the nomenclature. And there will definitely be nomenclature on the exam. There's a little bit less than I would normally put on the exam, but there is still some nomenclature. You should be able to name molecules from any of the 3, kind of 4 different categories that we looked at here. So the ionic compounds you can kind of split into 2 groups. There's the metals that only form 1 ion, and then metals that form more than 1. I kind of think of those as 2 separate groups, even though they are closely related. There's the molecular compounds, and then there are acids. So you should be able to name stuff just like you did in the lab. And I didn't put anything too crazy in there. So you should be able to name molecules, and there will be questions over those on the exam. So that was the last really big chunk there. And I know I mentioned this in the videos as well, but I will not have hydrated stuff. There's no hydrated compounds on the exam. Any questions about Chapter 2?
None so far.
Okay. So then the last chapter here is a bit shorter, but it's pretty meaty. There's a lot of stuff in this shorter chapter. And it is all about moles and molar masses. And so there will be a decent number of questions about this concept on the exam. So first of all, understanding Avogadro's number and how to use it. That is going to be important. There will be questions. We're going to be using Avogadro's number to figure out, if you have this many atoms or this many molecules, how many moles do you have, or vice versa. So you should know how to do that. You should also be comfortable using the molar mass to convert from grams to moles, or from moles to grams. Either way. So that would also include then, you should be comfortable calculating the molar mass from the periodic table. So I could just give you a formula and say, what is the mass of 3.35 moles of this? And you should be able to say, okay, if I have 3.35 moles, I need to find the molar mass, and that will be just 3.35 times that molar mass. That will tell me how many grams I have. And so that's what it's describing here, is essentially this step right here. And you should also be comfortable going both of these steps. So there won't be as many, but there, and actually I don't remember if I required any of these or not, but I know there were some questions at least where you did have to go all the way from mass to molecules or atoms, or vice versa. But it's not all that much more work. It's just 2 conversion factors instead of 1. But you should definitely know how to do that, because there will be questions on the exam both over the molar mass conversions here and the molecule to mole conversions. Okay. Percent composition. I ended up not putting any of those in there. So it is still something that's relatively worthwhile. It doesn't come up quite as often as other things in chemistry, but it is still something that shouldn't be ignored. So I would like it if you still were able to do it, but I ended up not putting any of those questions in the exam. What I did put in the exam were questions about solutions, specifically questions about molarity and dilutions. So there will be questions about both of these. So the way that the molarity questions are going to be worded is essentially you're going to be trying to find, let me see. There we go. You're going to be trying to find one of these 3 things. So either the molarity, the number of moles, or the volume in liters. So I will give you a way of finding 2 of these 3 things. So you can, maybe I'll give you the molarity and say you want to make 2 liters of a 12 molar solution of this compound. How many moles would you need? Or how many grams would you need, maybe? Something along those lines, where I give you information for 2 of the 3 things, and you have to find a way to solve for the 3rd one. So there's a few different ways I could ask those questions, but the basic idea is use this equation here and use the information I give you to find one of these 3 things. So that's the molarity. And so we had multiple questions here, or a couple questions here, where we did similar stuff. So here we found the molarity of a solution. Here we figured out how many grams of something we would need to make a certain solution. And then here we figured out what volume we would need. So we actually did all 3 possibilities there. And then the other type of question, which will most definitely be on the exam, is a dilution. And actually, I think there's 2. I think I have you do 2. It's either 2 or 3, but I think it was 2. dilutions. And so it'll be something similar to what we did here, where I give you information for 3 of the 4 parts. So again, this equation just has 4 parts to it. The first concentration, second concentration, first volume, second volume. I will give you information to find 3 of these, and you'll have to solve for the 4th. And so the main tricky thing here is just working out which concentrations and volumes go together, and then doing the algebra. That's really the only thing that you have to figure out here. But there will be, again, I believe it was 2. I think I have you do 2. But maybe I put in 3, but I think it was just 2 that I have you do of dilutions. We have to use this equation specifically. I believe that is it, yes, because the mass percentage, parts per million, parts per billion, volume percentage, mass volume percentage, I put none of that in the exam. I covered it in the lecture because I wanted you to be familiar with it, but I usually cover that stuff in Gen Chem 2. So if you come back for my Gen Chem 2 class, we'll go over these units more in depth, and at that point I will actually expect you to be able to use these units and solve for things with this unit. But for now, I just wanted to introduce it because it is mentioned in the chapter, but I think it's more appropriate in the solutions chapter in Chem 2. All right. So that's all. I know it's a good bit of information. It's not a tiny amount of information, but it is what we need to have on this exam. Are there any questions?
Nope.
No questions. Okay. Well, if there aren't any questions, let me just, real quick before I let you go, remind you that we do still have assignments other than the exam this week. So we have Lab 4, I want to say, and we have a discussion board. But we do not have 2 labs like we did last week, or I think in my other class. Sorry, I'm getting my classes mixed together. I have to actually look at the schedule to be sure I know what I'm talking about. But we do still have other assignments that are due this week. So keep that in mind as you're working through the material. Don't get behind on those other assignments. If you have questions over the exam, remember that you have a few days here where you can prepare for it. You can even go back. Like I said, I'm going to upload this video onto YouTube, so you can even go back and re-watch my explanation of the topics if you want to do that, to help you prepare for the exam. But if you have other questions that aren't answered in the video, feel free to email me. I've been doing pretty good about responding to those emails within 24 hours. Sometimes if they happen to come in as I'm sitting here at the computer, sometimes I respond within seconds, but that doesn't happen very often. But I've been doing pretty good about responding to those. And I don't think there's anything else that I need to talk about. So if there are no other questions, I think I'll let you all go. So thank you, the 5 of you, for showing up today. Hopefully you found it helpful, and those of you watching later, thank you for watching, and I'll talk to you next week.